All right, let's go ahead and get started. Good afternoon. Oh, very good. You're on to me. All right, how many of you were in the managed availability session? All right, we're going to continue a little bit of that discussion in here because there is some managed availability stuff that the high availability team is responsible for, and so we're going to talk about that. How many of you are running 2013? How many of you have deployed a DAG in 2013? How many of you are running 2010? How many of you have deployed a DAG in 2010? How many of you do in 2007? Who's done CCR in 2007? Who likes answering questions? All right, wow, a few hands still went up. Okay. All right, so now we're going to talk about high availability and site resilience. If you are not on Exchange 2013, a couple of these things might be difficult for you to follow along with, but stay with me throughout it. I think it will make sense for you. I'm not going to go over all the individual new features that we have. We've already done those sessions many times. If you're interested in all the HA features, go to channel9.msdn.com and you can see many, many iterations of the Exchange 2013 High Availability session, which talks about all those features. I will mention a couple of them, but we're not really just going to say, what's new in 2013 because it's been out for a while. And so this session is going to go a little bit deeper into the platform and give you some things that really every DAG administrator should know. Now, everything I'm talking about applies specifically to 2013. So even if you're running 2010 and you've got a DAG, a lot of this stuff is new and different in 2013. So you won't be able to take all of these lessons back to your environment and act on them right away. But if you are in 2013, then you will want to jump on this stuff. So again, remind me, who is not on 2013? So 2007 or 2010. Wow, that's a lot of you. You guys are missing out. You are missing out big time. Now, sure, the prior versions can do things like automatically recover from disk failures and even some network failures and some server failures, but 2013 now has the advantage of also being able to recover from data center level failures as well. So how many of you are in a site resilience topology where you've deployed your DAG across more than one data center? All right, so that's the kind of stuff we're talking about. How many of you only have 2 data centers? All right, how many of you have 3 or more? All right, I've got something for both of you today. Some of the other benefits that you get, failover times. They're half the time or twice as fast in Exchange 2013. Now, in both 2010 and 2013, we talk about database failovers happening within 30 seconds or less, and that's true. But quite frankly, 30 seconds from a computer timing standpoint is a very conservative figure from our perspective. As an example, in our dog food and our production environments for Exchange 2010, we see database failovers happening in around 20 seconds or less. So for Exchange 2013, we now see database failovers happening in our production environments at about 10 seconds or less. But of course, we can't guarantee 10 seconds, so we generally say 30 seconds or less, your database will fail over and become active somewhere else. So we have done some improvement there. We've also introduced a new architecture design called multiple databases per volume. That's what you see down here in this bottom part of the graph, where literally each one of these cylinders, each one of these gray cylinders at the bottom here, is a single disk. Okay, and by that I mean like a 7,500 RPM SATA or SAS disk, preferably SAS since they tend to have a better enterprise duty cycle. But SATA or SAS disks are supported. And that's one disk. It's not protected by RAID. It's in a JBOD configuration. That means just a bunch of disks. In other words, no RAID. JBOD is not new. It's actually what we used before RAID was invented. So it's a very old type of configuration. But when you look at this configuration, you realize with 2013 and this type of layout, we're pretty much telling you to do the opposite of what we've told you to do with generally all the other prior versions. So in the past, if you're running, 2003, for instance, going a little old school, we tell you, protect your databases with RAID and separate your logs from your databases for resilience purposes and recovery purposes. Now we're saying the opposite. We're saying don't use RAID. We're saying use just regular disks. And guess what? On that disk, don't just put one database, but put multiple databases on there. Plus the log stream and the content index for the database as well. And this is, in fact, how we run in Office 365 for all the servers that are running Exchange 2013. And we specifically invented this configuration to handle the disparity between maximum database sizes and the fact that hard drives are getting bigger and bigger and bigger. Okay, so a lot of customers today are buying 4 terabyte hard drives. Some eventually will be buying 6 terabytes, and maybe by this time next year, you might be buying 8 terabyte drives. Okay, but our maximum database size, if you're replicating it, we recommend growing that database no larger than 2 terabytes. So now you have this conflict to resolve. Do you grow the database much, much larger, beyond the 2 terabyte recommended limit? Or do you waste a bunch of disk space? Well, we don't want you to do either, and so that's where multiple databases per volume comes into play. So imagine if each one of these cylinders were an 8 terabyte volume, you could comfortably fit 2 terabyte databases for them on one of those disks. Okay, so that's how we get around that problem. We don't want you to grow your databases larger than 2 terabytes, even if you're replicating them, simply because eventually you're going to have to reseeding those databases. And a reseed operation has to complete from start to finish. So if you grow your databases to 3 terabytes, 4 terabytes, 8 terabytes if you want to fill the disk, now you're running into a problem. If you have 8 terabyte database and you need to reseed that, the best case scenario is it will take you 93 hours to do that over your network. Okay, 93 hours is operationally untenable. It's a no-go. But in a multiple databases per volume configuration, if you still have 8 terabytes of data to seed, but it's carved into 4 separate databases, you'll actually be able to reseed all 8 terabytes because it's carved up that way and coming from multiple sources in about 39 hours. It's a much better story that way. So you get faster reseeds. That was actually the point of the bottom one, about 58% faster reseeds when using multiple databases per volume. But at the same time, you're leveraging the full capacity of these disks while still adhering to our maximum database size. So multiple databases per volume, it seems like it might be new and different, and it is, but it's also something that we have a lot of faith and investments in, and it is part of the preferred architecture. All right, so what have we been doing since RTM? We've been doing a lot. And when I say we, I'm really just talking now about the Mailbox Intelligence feature team within Exchange. This is the feature and component team that's responsible for the high availability features like the DAG and database copies. And it's also the team that owns the extensible storage engine, the managed store, and parts of managed availability as well. So when I say we've had 620 check-ins, that is just that team. So that doesn't include all the other stuff that all the other component teams are doing. This is just the HA, the Mailbox Intelligence team. And we've done a lot of stuff, like we've simplified the DAG by leveraging a Windows 2012 R2 feature that allows you to create failover clusters without administrative access points. We'll talk a little bit about that. And I'll also talk about that in the tips and tricks session as well, because I've got some tips in that area for you. We'll talk about the new DAG management service, loose truncation, some of the new monitors that we have for managed availability, and we'll talk about some of the settings that administrators have to control server resource consumption in terms of active databases and failover behavior within the DAG as well. So responding to failures. So again, this is talking generically about the HA team within Exchange. So typically, when we think about failures, and we think about them all the time because we do run the world's largest Exchange organization, so every day we have to deal with multiple failures of some sort simply because of the scale at which we operate. So when we typically think about failures, there are 4 different ways we can address them within the product. So one might be to find and fix the root cause code. So if it's a code bug, something in Exchange, we'll track that down and we will fix that bug and stop those problems. We might also do stuff within the product to recover the client experience. A lot of the things that I talked about in managed availability, such as failing over when a protocol is not working to recover service on another server, that's an example of recovering the client experience. We might also do something like repair the symptom. There are, I don't want to use the term self-healing capabilities because that is a bit misleading. It's not 100% accurate. But there are many self-recovery behaviors within Exchange so that it can recover or in some cases repair a problem through some recovery action. And then we can do things like remove complexity from the product. So let's talk about the first one, removing complexity. So let me focus in on why we did something, and then I'll explain what it is we actually did. So again, remind me who here is running a DAG in any version, 2010 or 2013. All right, so almost all of you. So hopefully all of you are aware that every DAG has multiple cluster resources associated with it. Okay, those are going to be IP address resources, network name resource, and if you have an even number of members in your DAG, there's also going to be a file share witness resource. Now, from an Exchange perspective, the only one we really care about is the file share witness resource. We don't care about the DAG name. We don't care about, or the cluster name for that matter, and we don't really care about the cluster IPs. Now, every single DAG in Office 365 is stretched across geographic boundaries, so they're all multi-subnet DAGs. So, as you probably know, for all DAGs, when you are in a multi-subnet environment, you need an IP address for the DAG itself on every network that you're using in your MAPI network. So here's an example of what that looks like. That you can see here, just looking at the resources for this one DAG, we've got the cluster IP address, and then we've got IPv6 version, and then we've got another cluster name, and because we're in multiple subnets, we've got multiple IPv4 and multiple IPv6 address resources as well. Some will be online, some will be offline. It depends on what subnet that cluster group is currently hosted on. Whatever subnet it's on, that's the IP address that will be online. Now, all of these things are cluster things. They have nothing whatsoever to do with Exchange. And in fact, Exchange doesn't use any of these resources at all. Not interested in them, don't use them, don't need them whatsoever. However, because they're cluster resources, if they go, like the one you see there, into a failed state, then that raises all sorts of alarms and alerts because now the cluster is deemed in an unhealthy state. And because the Exchange folks are managing that cluster because it's below a DAG, the Exchange folks have to go and chase this stuff down. So here we have cluster resources which we don't need for Exchange, but Exchange has to troubleshoot them in the service. And we have to do that all the time because we're using Windows failover clustering. Well, along comes Windows Server 2012 R2. And what it allows you to do is to create a DAG a DAG whose cluster does not have an administrative access point. Now, the cluster defines an administrative access point as the network name and one or more IP addresses. So if you're creating a cluster without an admin access point, that means no network name. Okay, you still have to give the DAG a name, but that name does not go down to your cluster. The cluster itself will not have a name. In addition, you have the ability to create it without IP addresses. So the cluster itself and the DAG itself will not have any IP addresses whatsoever. So what you end up with is a resource group that looks like this. You know, just the one resource, just the file share witness, which obviously we still need for even member DAGs. Okay? So it makes the DAG a lot simpler and a lot easier to manage, particularly in a large-scale environment like Office 365. Now we don't have to go chasing those IP address resource failures, especially when it's a component that we don't even need or use in the first place. Now, there are some third-party products that integrate with Exchange that do use the cluster admin access point. Backup and management software being the biggest culprits. They will connect to the name of the cluster and to whatever server is hosting that cluster group using whatever IP address resource is assigned to that subnet. Okay? That will break if you create a DAG without a cluster admin access point. So in this product, this is an optional configuration. You will always have the ability to create an old school DAG that has the IP address point and the admin access point, or you now have the ability to create a DAG without one. In the next version of Exchange, which we've said is coming out late next year, this will be the default configuration. Okay, so by default, all DAGs in Exchange vNext will be created without an admin access point. We will, however, always give you the ability to create a DAG with an admin access point. Okay? That will always exist because there will always be some third-party requirements for that. We don't like it, but it's a fact. So if you're using a third-party solution that's using it, you're safe, you're fine, nothing is going to change. If you're not using any solution that uses it, then I would recommend going down this route. But of course, you do need Exchange 2013 SP1 and Windows Server 2012 R2 in order to do this. All right. Now, this is not entirely new, but it's not as well known as some of the other services. So most of you are probably familiar with the Microsoft Exchange Replication Service. That's the service that handles continuous replication. That's the service under which Active Manager runs and so forth. But that service started getting a little bit too bloated. It was handling too many functions. It was handling critical functions like the continuous replication pipeline, but it was also handling non-critical functions like lag copy management and so forth. And so what we did is we refactored that service. We took out a lot of the low-level functions that were present in the replication service, and we moved them over into this new service called the DAG management service. And this allowed us to do two things. The primary benefit that we get is it moves the high critical functions away from the low critical functions and separates them from a process standpoint. And in doing so, that not only makes the replication service leaner and better, but it also means that managed availability now can target these low-level activities for termination without interrupting continuous replication. So as an example, the DAG management service is having some sort of an issue with one of its functions. Managed availability can terminate and restart that service, and the replication service is completely unaffected by that. So it's a win-win from an architectural standpoint. You should expect us to offload more functionality that exists in the replication service today over into the DAG management service. Some of the things that are planning on going over there eventually are things like auto reseed, the ability to have the system automatically reseed a database. And I'll show you what that looks like in a bit. But auto reseed functionality, disk reclaimer functionality, which works with auto reseed to grab that spare disk, that functionality will also be moved into the DAG management service as well. So now you're going to have two services that will be handling all of the aspects of the DAG instead of just the single replication service. Now, in terms of lag copy management, that's something else that is dramatically improved in 2013. So how many of you are using lag database copies in 2010? All right, and how many of you are using them in 2013? How many of you wanted to use them in 2010 but found them too hard to manage? A few hands, okay. And this is actually one of the things that we did in 2013 to try and resolve that. We wanted to give lag database copies the ability to care for themselves in certain situations. So one of those situations is the volume on which it's stored is running out of disk space. And that can happen with a lag copy because it's building up its logs and not replaying them right away due to the nature of the lag copy. So that can happen. And so we had the ability for the lag copy to automatically play log files forward until there's sufficient free space to not trigger the threshold anymore. Similarly, the lag copy can now be page patched automatically. We couldn't do that in Exchange 2010. We could only page patch an active or passive copy, but we couldn't do a lag copy. If you're not familiar with page patching, it's a mechanism whereby we detect page corruption in a database. You may have seen this. It's a negative 1018, negative 1019, 20, 21, 22, any one of those ESE corruption events. When we see those, page patching allows us to get a clean version of that page from a replica of the database and basically patch up the one that has the corruption and fix the corruption problem. In 2010, we couldn't do that with a lag copy because it's quite possible that the transaction records for that page haven't even been played into that database yet because of the lag nature of it. So now what we can do is if page patching is required by a lag copy, the lag copy can again automatically bring itself up to the point where it now has the page in the database, and then it can pause, replay, and invoke the page patching mechanism. And then the third scenario is when redundancy is compromised. So if you have fewer than X number of copies within Y time interval. So the default is fewer than 3 copies within a 24-hour period. The lag copy can bring itself up to date and become a viable passive copy for activation. So for those of you who may have been wary about lag copies, the behaviors around lag copies in 2013 is significantly improved, and we have integrated the lag copy into our preferred architecture as one of those copies of your databases. So a preferred architecture would have 4 copies of every database, 1 active, 2 passives, and a lag copy. So I mentioned auto reseed. How many of you have heard of auto reseed? Okay, a few of you. Oh, actually a few more hands. Okay, so if you haven't heard of, it's a very cool feature. I will tell you, it is a little tricky to deploy, in part because it requires multiple mount points pointing to the same location, and there is a hard-coded directory path that you have to adhere to in order for it to work. So auto reseed is one of those features that was created in Office 365 and put in the on-premises product because of how beneficial it is. So again, thinking about Office 365, where we've got hundreds of thousands of databases on hundreds of thousands of disks, we're going to see disks fail all the time. And if we had to send an administrator or an operator out to go replace a disk and then initiate a reseed operation, we would be doing that every day, all day. That would be too expensive to do. So instead, we taught the system how to do it. So the way it works is I've got this server in the middle. It has its in-use storage pool. Those would be the disks that have databases on them. Each one of those is a single JBOD, so non-rated disk. And then it's got some spare disks down below. And the way it works is when you lose a disk, obviously it's taking out the databases that are on there, so their copy status goes into a failed and suspended state. And when that happens, that triggers the auto reseed workflow. And the auto reseed workflow will grab one of those spare drives, and it will mount it into the path where it needs to be, and then it will automatically invoke a reseeding operation so that the database or databases that were on that failed drive get automatically reseeded by the system. It's a very, very slick piece of technology. Now, it is much easier if you build a DAG with auto reseed in mind, again, because you're dealing with hard-coded directory and database paths. You can take an existing 2013 DAG and retrofit it, but that basically involves moving database and log paths, which is going to result in downtime for you because you have to take all copies down to move a database location. So if you're contemplating auto reseed, but you haven't deployed 2013 yet, do your auto reseed configuration ahead of time, even if you're not going to leverage the feature. Then later on, when you're ready to leverage the feature, your DAG is already built out and good to go. It'll save you some downtime. All right. Now, why? Again, it's all forgetting about replacing disks as they fail. So here's the formula. Okay, this is the actual formula that we use to determine the probability that we'll need to replace disks more than once a month. So we're looking at 1 minus a binomial distribution. If you're familiar with the concept of what's known as Bernoulli trials, what this basically means is that each independent disk failure is treated as its own isolated incident. And the fact that one disk fails has no bearing on the likelihood that additional disks would fail. So in other words, these are individual isolated events that we're calculating the probability of occurrence. So what we're looking at is we're looking at the number of spares plus 1, the number of disks we have in the servers, the annual failure rate divided by 12, and then multiply that by the number of servers. So you find the values for the variables that are there, the spares, the disk per servers, and your AFR. You plug that into this formula, you put it into Excel, and it will calculate the percentage that you have to replace disks on a monthly basis. Okay? If you're not familiar with AFR, that's the annual failure rate. Okay? That's the rate at which your storage vendor says they expect your drives to fail. That rate is going to vary from vendor to vendor and from disk type to disk type. So you'll need to ask your vendor what their AFR rate is for your specific disks. Okay? Because it can vary widely, anywhere from like 2.25% on upwards of 5%, or maybe more depending on the type of disks. So when we plug this value in, just as an FYI for fun, when we plug this value into the metrics that we have for Office 365, it says there's a 9,905% chance that we'll have to replace a disk at least once a month. And it turns out it's right. It is pretty spot on. But you can plug that in, and that will tell you if you'll actually get benefit of auto reseed. Because if you have to send an administrator to do that, remember that includes the reseed operation, which has to be babysat. So the admin has to kick it off, and then they have to monitor it the whole time. Because if there's any interruption, if the network hiccups or the process stops or anything happens, the reseed has to start back all the way from the beginning. Okay? So it's best to let the system handle that because the system is programmed with automatic retries and things like that. So use this formula. It'll help you figure out as to whether or not you need auto reseed. All right. recovering from storage failures. So this is one of those areas where it sounds like self-healing, but it's really self-recovery, because when you think of self-healing, that's actually fixing the original problem. That's not always what we're doing here. We're really just recovering from the problem, and by that I mean we're restoring a user service and data access as a result of some action that we're taking. Now, some of these behaviors are not new in 2013 or 2013 SP1. So all the behaviors that you see listed for Exchange 2010, we had all those in 2010, and we've carried them forward into 2013. 2013 RTM, we added the next section, and then in SP1, we added one more. These are all failures where we know the only solution in the past would have been to send an administrator out to hit the power button to recover from these failures. So now, instead of doing that, we teach the system to recognize these conditions and self-recover by bug checking the box. If you're not familiar with the term bug check, maybe you're familiar with the term blue screen. It's the same principle. What we're doing is there's a process in Windows called winInit.exe. And when we need to bug check a box, we have the replication service terminate that. That causes a unique stop code, so you'll always know when it's us bug checking the box versus an actual blue screen. And that, of course, causes an immediate reboot of the system as well. You can try this on any Windows system. Those of you that have laptops right now, fire up Task Manager, locate winInit.exe, right-click, and choose End Task. Save your work first, because it's an instant blue screen. Yes, instant blue screen. I should mention that first. Yeah, so that's all we're doing. Is when the replication service or when Exchange itself encounters one of these problems, it bug checks the box to move service and data over onto another system. Now, most of these things are storage related, but a couple of them are service related. So if the replication service just can't be restarted within about an hour's time, we'll give up and bug check the box and move everything over. If the replication service memory goes above 4 gigabytes, we'll actually terminate the service rather than bug check the box, and then allow the service to reinstantiate. If it goes over 4 gigs again, then we'll bug check the box and move service over. All right. Now, as I've mentioned a few times now, we run the world's largest Exchange deployment. Now, a lot of the information about that deployment is proprietary, and we're not allowed to talk about it, but there are things that I can tell you about it. So as an example, we have 26 data centers located worldwide. We have more than 125,000 databases, and actually it's a lot more. We're just trying to be conservative here with the numbers. But all of those databases, we have almost 4 nines availability of. Okay, so we're greater than 3 nines, which is almost what you could get out of the box with today's Exchange. Our average database failover time is around 15 seconds. As I said, sometimes it's more closer to 10 seconds. Sometimes it's a little bit longer, especially if we're moving out of site, but it averages around 15 seconds. And then for site switchovers, we exercise those regularly. We will literally do hundreds of manual site switchovers a month to validate that everything is working, not just from a single data center perspective, but from a multi-data center perspective as well. So we are constantly, intentionally exercising our switchover code. And then there's also tens of unplanned outages that we have as well. And those are things that are typically out of our control, often network-driven or some sort of natural disaster or some other type of activity that drives us to have to move service over to another data center. And the fact that we are constantly exercising our site switchover code is a valuable lesson you can learn from us. That is something that we really would want customers to regularly exercise as well. Because if you're not doing that, you're not going to have a very smooth switchover in the event you have some data center level event. Now, I've got a couple charts up here as well. Let's talk about the graph here, this 1 copy minute per database. And that goes actually farther back in time. It goes several years back to when we started collecting this data. And this chart represents the number of minutes that a replicated database was in a single copy state. In other words, that was the only viable copy of that database. And the trajectory that you can see, let me zoom in on this in case it's hard to see for some of you. The trajectory that we have for this chart is exactly what you would expect. You would want it to be on a downward angle. So, when we started out years and years ago and we were just getting started with our workflow and all our redundancy mechanisms, we had some database copies that may have been in a single copy state for as long as 10 minutes. Now, I know 10 minutes doesn't seem like a very long amount of time, but during that 10-minute window, I can tell you there's a high level of stress where you're worried about something that's going to happen to that last copy. But now you can see here we are moving into, this would be November of last year, or excuse me, November of last year. So now you can see we're getting down to around 1/100th of a second that the database will stay in a single copy state. So significant reduction in exposure and vulnerability as we have learned things by moving forward. The other chart, this is actually one of the charts we use to look at the effectiveness of managed availability against the DAG and the HA stack. So here you're seeing a list of all the different responders that we have. So restart responders, failover responders, reboot responders, and so forth. And how many actions were taken on a weekly basis per server based on these. And so you can see actually the two up at the top, those are our most important two. I'm going to talk about those in a minute. But those are the ones that we would expect to hit the most anyway. All right. All right, let's talk about monitoring and server maintenance. And again, this is dovetailing into the managed availability discussion we had last session. If you missed that session, I'll try to make it easy for you to understand what we're talking about here. And if you were at that session, hopefully this will help reinforce it. So the primary purpose of managed availability is to find some degradation of service that's affecting users, something that is affecting one of those three touch points of the user experience, the availability, the latency, or errors. Then it's going to attempt to recover from failure, and if recovery fails, it escalates to the Exchange administrator. It's fairly simple logic when you think about it from that standpoint. So managed availability has a bunch of probes. Those probes are there collecting data. That could be performance data. They may be using synthetic transactions to evaluate the end user experience. And they're sending all that data over to the monitor. And the monitor is where we have all of the business logic around managed availability, where it will take the data and analyze it and then decide if some sort of responder activity needs to take place as a result of some kind of bad situation that it's discovered. Okay, so this is really the plumbing of managed availability. And again, it applies to all the different components within Exchange. And each component team implements managed availability in a slightly different way that is unique to their actual component. So we've already talked about get server health and get health report. If you weren't in the managed availability sessions, these are the two primary commandlets that you'll use to view the health sets on a server and to view the managed availability probes and monitors and responders that are associated with a given health set. These are also the commands that you'll use to find out the health of your servers. And there's a mechanism whereby you can get the health of an individual server, or there's also a command that you can run that will give you a roll-up of all of the server health for an entire database availability group as well. And as I mentioned, the complete set of all of the probes and monitors and responders, they will be in the Crimson Channel event log. That's that application and services area of the event log where we store everything related to managed availability. Now, HA managed availability, that would be the mailbox intelligence team, leveraging managed availability to manage our components. So leveraging them to manage things like the data protection health set and the clustering health set. So we're interested in using managed availability to monitor the replication service, to monitor the copy queue length, the replay queue length, the available disk space, the health of the cluster, the health of the replication pipeline, the health of lagged copies, et cetera, et cetera. Okay, these would be part of the data protection and clustering health sets. So if we were to look at all the monitors that the HA team uses, there's several, and I'll actually build them up. All of the ones that you see here in yellow are ones that we just added in Service Pack 1. Everything else in white has been there since RTM. And so you can see there's a lot of different monitors related to the cluster health, redundancy, service health, database health, lost flushes, which are the ESE ones, storage space, and database copy status as well. Now, out of all of these managed availability monitors that the HA team uses as part of the data protection and clustering health sets, it's really these two that are the most important: the Server 1 copy monitor and the Service Health MS Exchange REPL endpoint monitor. Okay, so let me dig into those. The Server 1 copy monitor, this is HA's most important monitor. Okay, how many of you are aware that in Exchange 2010, the task scheduler service is required on all of your mailbox servers? How many of you knew that? How many of you know why? You know why? Shout it out. Why is that? God, I wish I had a prize to give you. I don't, except I'm going to call this guy out as this guy knows what he's talking about. How's that for a prize? Yeah, you're exactly right. Give him a hand. That's right. You'd be surprised. Hardly anyone ever gets that. So his answer, if you couldn't hear it, was the Database 1 copy monitor. Okay, so some history on this. After we released Exchange 2010, but before we released Service Pack 1 for Exchange 2010, we released a script through the blog called the Single Copy Alert script. And you could go and take this script. It was actually not just a script, but also a task scheduler XML definition file so that you could download these things and have this script automatically run. And this script was designed to log alerts in the event log whenever a replicated database was down to a single copy of that database. It had nowhere to fail over to. That's why we call it the Single Copy Alert. We shipped that script out of band in between major releases, in between RTM and SP1, because we thought it was critical that customers have that script and have that visibility, particularly since we've been promoting JBOD even back then. So if you're a customer running without RAID and you've got one copy of your database left and it's on a non-rated disk, you need to know about that right away. We want the administrator to be on top of that situation, because if you lose that disk, there goes your last copy of the database. So we released the script out of band. Then in SP1, we took it one step further. We made the task scheduler service a required service for the mailbox server, and we installed the script automatically into the task schedule for you. You no longer had to do anything. So if you haven't looked, if you're running 2010 today, go fire up Task Scheduler and you'll see a job called Database 1 Copy Alert. That is Exchange scheduling that script. Now, that script and the dependency on Task Manager are gone in 2013. Now, the Server Copy Monitor takes its place. And this is a monitor that, even though it's managed availability, actually runs inside the replication service, not inside the Health Manager service. It's the replication service that is responsible for invoking this monitor and notifying an administrator if they're in a single copy state. So once a minute, we check each database on each server. And what we're looking for is that we want to make sure all the copies are healthy mounted. We want to make sure that the server component state, which refers to the managed availability responders, is not offline. We want to make sure that the copy's not activation blocked, either at the database or the server level. We want to make sure that the server is not exceeding the maximum active number of databases if the administrator chooses to set that. And we want to make sure that the copy queue length is less than the auto database mount dial as well. Okay? So that's what we're looking for to verify that we've got multiple redundant copies that we can use. And the way it works is if we see that, remember we're checking once a minute, if we see 30 consecutive failures, so if we see this in a state for 30 minutes or less, we will notify the administrator by generating events through the escalation mechanism. All right. Now, the other monitor that's very important, not quite as important as the single copy monitor, but very important from an operational standpoint, is this Service Health MS Exchange REPL endpoint monitor. So here, again, we're just looking at the 3 endpoints that we have for the replication service to make sure that they're responding. So to do that, we use 3 probes and 5 responders. We need to check that it's responding from a TCP level, from an RPC level, and from a server locator level. And if it's not responding from one or all of those, then we've got a whole bunch of responders we can initiate. So you'll see, starting at the top, you see restart responder and then restart responder 2. Okay? So here's where we might start a service, and if the service didn't start correctly, we might try to restart it again before taking some other action. So that's why you see restart responder 2. Obviously, if restart responder 2 doesn't get the service running, then we'll fail over the databases. And after we fail over, we still have this issue of needing the replication service starting, and if we can't get it started, we'll try to resolve it by rebooting the box. And if that doesn't fix it, then the escalate responder will get in and log an event for the administrator to know that they've got a problem that needs their attention. All right, let's talk about DAG server maintenance. This has also changed substantially over Exchange 2010. And I don't mind saying that we did it in a way that it's going to be, unfortunately, confusing for you. So in Exchange 2010, we included 2 scripts. Start DAG server maintenance.ps1 and stop DAG server maintenance.ps1. And those scripts would basically quiesce the DAG member, move all the active databases off, block it from activation, move the PAM role off if it was the PAM, pause the cluster node so it couldn't re-inherit the PAM, and basically do a whole bunch of stuff to get the server ready for maintenance. So that process is different. The process is a lot more complicated because of the architectural changes. You know, in 2010, your DAG member might have been just the mailbox role. In 2013, all your DAG members have mailbox, hub, and the legacy CAS on them now. So you've all are running basically multi-role Exchange 2010 servers on your 2013 single role boxes. And of course, we would want you to combine that with CAS as well in a multi-role configuration. So we've got multiple roles installed. And so you've also got the potential for servers, namely the CAS part of a server, to be serving clients and proxying that communication to another server. So they're not going to the mailbox part, but they may be using the CAS instance of it, or they may be using the transport instance of it, or the components. So you basically have to quiesce client activity now. So I'm not going to walk you through the actual commands because those are documented in TechNet, but I did want to basically break down the process for you. So because you've got both transport and on the box, you basically need to pause them. You're going to be draining their queues. Now, in the case of transport, we do have a redirect message PowerShell commandlet that you can use to take messages that are in a queue and have them sent over to another queue. And that will be a faster way of draining the queue if you wanted to do maintenance. Then you would suspend the cluster node, then you would activate, disable the server, activate, block the server, and then turn the managed availabilities responders offline. Now, here's the unfortunate thing that makes it difficult for you. We do not include any scripts in the box for you to do this. We have the commands documented on TechNet, and you can copy and paste them into your own script, but we don't provide the scripts for you. However, what we did do is the stop DAG and start DAG maintenance scripts we did unfortunately ship in 2013, and they're deprecated. We don't want you to use them. Don't use them for maintenance mode. Even though they're still there, just ignore them completely and forget that they're there. Eventually, we will remove them from the product, but they're in a state that's called deprecated right now, which means they're in this version, but we don't want you to use them, and they'll be gone in the next version. All right. Best copy and server selection. Let's talk a little bit about that. That has changed a little bit. There are some things that are still the same, but there's a bunch of things that have been changed as a result of the integration with managed availability. So the BCS process, we actually call it best copy and server selection now in 2013. We just called it best copy selection in 2010 because we weren't evaluating server health. In 2013, We're evaluating the health of the server on which the failure happened, and we're comparing that with the health of the servers that have viable passive copies for us to activate. So now there's a whole lot more that goes into this algorithm. It's still an Active Manager algorithm. Active Manager still makes all the decisions about BCS. It's still performed at star over time. Star over is short for switchovers and failovers. So if it's a failover or a targetless switchover, the BCS algorithm will still act the same. We're still using the extracted system health of the DAG, so that would be the copy queue length, the replay queue length, the database state, and the copy index state. And we're still using the same replication criteria and those 10 phases that we have documented for Exchange 2010. But now there's some new things that we can do. So for instance, there's a cap on the replay queue length. Okay, so if you have a replay queue length greater than 200,000 log files, that won't be factored in to the best copy and server selection because it'll take too long to mount something that's 200,000 log files behind. We also give administrators the ability to add a maximum databases, both a soft limit and a hard limit. The hard limit and soft limit can be overridden as well, but they are enforced in the absence of overriding them. They are enforced within the BCS algorithm. And then, as I mentioned, we're also including the protocol stack health. So if the problem that we're trying to recover from is Outlook Web App or ActiveSync is not functioning on a server, we need to evaluate the health of Outlook Web App or ActiveSync on the other servers to figure out if we have a good place to move to. So there's other activation controls that you can put into place as well. And let me show you this table here to illustrate how they can go. So one is just using our redistribute active databases script. This is a script that we released in 2010 and carried forward into 2013. And this is there for you to use to balance your DAG according to activation preference, both within or across multiple AD sites. The other two values that we have, one is called maximum prefers active. That's a soft limit. It's kind of a suggestion for Active Manager that says, you know, this server can have more databases, but I really want it to have just fewer ones. So if there's another server that has more resources, move there instead. Only move to me if you absolutely have to. And then there's the max active limit, and this is a hard limit that says if I've reached the maximum number of mounted databases on that server and I've got nowhere else to go, I'm not going to fail over. I'm going to dismount that database instead. So we give you varying levels of control. One is a soft limit, the other is a hard limit. They do sound the same. One is max preferred active databases, the other is simply maximum active databases. So maximum active databases, that, because it's the hard limit, that's the worst case. Again, a hard limit means it will favor dismounting a database versus failing over when it hits that limit. We will enforce that limit. And that could be a problem for you if you don't have any other place to go. So I would strongly caution you to only use a hard maximum limit if you actually understand all the different failure scenarios that can happen to you. If you don't understand them, use the 2013 server role requirements calculator, even if you've already deployed Exchange. Plug in your numbers, and it will give you on one of the tabs a layout of what it thinks your DAG should look like. All the servers, all the databases, the activation preference, whether or not they're across a WAN, and so forth. And there are buttons you can push within that tool that will simulate failures and show you where databases would fail over to in a perfect world, assuming everything is healthy. So that gives you a way to model things before you actually put in a hard limit. Now, the maximum preferred active databases, this is new. This just came in SP1. And this is a soft limit so that the administrator can control resource utilization on a given server. The server might be sized to handle 28 active databases, but maybe they only want it to really one with 20 active databases to optimize the user load and so forth. So they can set this soft limit, which will be prioritized and used within BCS, but it's not an enforced hard limit where BCS will dismount instead of failing over like it will the maximum limit. This is really just a suggestion in hopes of trying to do load balancing of the load during a failover scenario or a targetless switchover scenario. Now, you can skip them both. Even if you have both of these values configured, and they're both configured at the server level using set mailbox server, when you're activating databases with the commandlet, if you move active mailbox database with the skip maximum active database checks, then both of those values are ignored, and you can forcibly mount a database on a server that would be above whatever maximum you set. So we will skip looking at those values. So we do give you a way out in an emergency basis. But that is a manual thing. This is not automatic failover in this case. This would be the administrator probably realizing they ran into the hard limit and then forcing them out to get service back to that database. Now, I mentioned before that there is a difference between managed availability failovers and the normal, or what we would call the active manager failover logic. So looking at the normal failover behavior, all of this is largely the same as what we were doing in 2010. The primary difference is that we're now looking at managed availability health sets. And we're looking at the actual state of individual health sets to see if they're healthy or unhealthy. And we're comparing them with the state of the health sets on the server where the failure occurred. We do that so that we can enforce within the algorithm that failover will never make anything worse than it already is. Okay? Now, failover might not make things better because we have the capability of failing over to a place whose a server whose health pretty much matches where we came from. But we will never fail over to a place where any of the health sets are in a worse state than the server on which the original failure occurred. So we impose that constraint in the algorithm to make sure that failover never, ever makes anything worse. In the case of managed availability, its logic is a little bit different. So it will still look at the source and the target, but the normal failover has varying degrees of evaluation of health that it can go through. All we're looking at from a managed availability failover is whether or not the health sets that are affected on one server are in a healthy state on the other server. If they're not in a healthy state, we will skip that server. It won't be a candidate for a managed availability failover. We want all health sets to be healthy, and if we can't find that, we'll look for any health set that has a medium priority or above that's in a healthy state. Now, I know we didn't talk about this in the managed availability session because now that is really getting into the nitty-gritty of the health sets. But the fact is that every health set has a priority associated with it. Okay, as you might imagine, some health sets are higher priority than others. An Active Directory health set, a DNS health set, the data protection health set, those are all super high priority health sets. POP, IMAP health sets, they're lower priority health sets. Okay? That kinds of things. So we're looking at any health set that has a medium priority and higher, we're looking for that to be in a good state. And if we can't find that, we'll look at just a server that has all of its managed availability health sets in a better state than what happened on where the failure occurred. Okay? And if we can't find something that meets that criteria, then there won't be any failover. We will not make the situation worse as a result of failover. We're only looking for something equal to or better. And we try to find something better first. If we can't find that, we'll look for something equal to see if it might make things better. But if it doesn't, we'll never go and make things worse. All right. So the last 20 minutes, we're going to talk about site resilience. Remind me again, how many of you have a site resilient DAG today? All right, and the 2 data center people are there, and the 3 data center people. Okay, and 4 data center people? No, I'm just kidding. We'll only care about 3 or more. Okay, so let's talk about a new server setting. This, again, is also another set mailbox server. It's database disable and move now. This is designed specifically for moving data and service to another site as quickly as possible without doing the obvious thing of just powering off all the servers in the primary site. This is doing a normal, orderly move and moving the databases off very fast and also disabling activation but allowing the server locator process to stay running. Okay? So that server locator process is actually probably not very well known amongst customers, but it is a critical process that the replication service performs because it's not just related to Active Manager and DAG functions, it's also responsible for responding to server locator request calls from the Active Manager client that runs within the client access server. So in terms of blocking activation, there's 3 different ways that you can do it. You can do it on a database level. You can do it on a server level and just say block everything. Or you could do it on a server level and have things be disabled but still allow server location requests and still allow database mounts, but it'll just move it over after that mount happens. So let's talk about the top one, suspend mailbox database copy. You would use the parameter -activation only. And this takes an individual passive copy and suspends it from automatic activation. Okay, that's all it does. Continuous replication still works. We'll still ship the log files over there. We'll still inspect them. We'll still replay them and keep that database up to date. But the system will not automatically activate that database copy. Think of it as a DR copy, if you will. Now, the other two, database copy auto activation policy and database copy activation disabled and move now, both of those are per server settings. One is designed to just block activation. The other is designed to disable the databases and move them off to another server. Now, one thing to keep in mind, that database copy auto activation policy, that can have unpredictable results for you, and I'll explain why that is in a minute. But the database copy activation disable and move now, that is very safe to use, and it's something that we would recommend if you need to very quickly either activate a different site, or if you need to just test your site resilience strategy like we do, as I mentioned, hundreds of times every month. You should be testing yours as well, and that will help you do that very quickly. All right. So I think the database copy auto activation policy note I wanted to talk about is in the tips and tricks session at 5 o'clock tonight. But in case you can't make it, I'm going to tell you what the challenge is there, because it does catch some customers off guard. So if you have a bunch of servers in another site and you want them to be true DR servers and not have the system automatically activate them, what many customers will do is they'll run set mailbox server and they'll configure database copy auto activation policy with a setting of blocked. Okay, that basically blocks all databases on that server for activation. And typically they will do that for all the servers in their DR site. Now, that blocks automatic activation. We still always give you the ability to manually activate a database. But if all you have left is servers in your DR site and all of them have the activation policy set to blocked, even if you manually mount and activate those databases, your clients still will not be able to connect. And the reason for that is when you set database copy auto activation policy to blocked, not only are we blocking activation, but we're also blocking those server locator calls. And when we block server locator calls, no clients can connect to the system. So, for those of you who are in a true DR site and you're using this, continue to use it, but just be aware, after you manually activate your databases, you need to go set that policy to unrestricted on at least one server in the DR site. At least one server has to accept server locator calls and route that traffic around. If you don't do that to at least one server, even if you manually activate your databases, your clients will not be able to access them. So keep that in mind. That catches a lot of folks off guard. We've since discovering the customer confusion around this, we have updated the documentation to reflect this, but it's basically buried in the commandlet help, so it's easily overlooked. All right, dynamic quorum. How many of you have heard of dynamic quorum? All right, I'd say 7 of you. 8. Okay. All right, so dynamic quorum is another one of those Windows clustering features, and because DAGs use Windows clustering, it's a feature that we're either going to like or not need or something like that. In this case, dynamic quorum is, I would say, semi-interesting for DAGs, and I'll explain why in a minute. So if you're not familiar with it, so in previous versions of Windows failover clustering, like Windows 2008 R2, which would be the first version in the legacy space that doesn't have dynamic quorum, quorum was always fixed. The number of votes required to maintain quorum in the cluster was always fixed and based on the number of nodes that you had in that cluster. So even if a node got turned off or turned back on, the number of votes required to maintain quorum still always stayed the same. In Windows Server 2012 and in 2012 R2, there's a new way. The cluster votes are no longer fixed. They are now dynamically managed, and it's determined by the 7 nodes that are active at a given particular time. Okay, and that could change. You might have some nodes that are up, some nodes that are down. The ones that are up have the votes. The ones that are down don't. And this is a new feature. It's enabled for all clusters by default, and it's called dynamic quorum. And again, it's in both Windows 2012 and 2012 R2. So the way it works is now the cluster is dynamically managing the votes, and it's recalculating the number of votes needed to maintain quorum after a failure has occurred, but quorum is still maintained. And by dynamically adjusting the number of votes required to maintain quorum, it gives the cluster the ability to sustain failures that it wasn't able to sustain before, and actually lose a a series of members and still have the cluster up and running. So that means a Windows Server 2012 or 2012 R cluster that has 64 nodes could actually suffer an outage of 63 of them and still have a running cluster. We call that the last man standing scenario. So that's the new capabilities of Windows failover clustering. It does not allow a cluster to sustain a simultaneous number of failures that result in the loss of quorum. Okay? In order for dynamic quorum to recalculate the number of votes that are required to maintain quorum, the system still has to have quorum. So any failure scenario where you've lost the majority of votes, dynamic quorum won't do anything for you. It's only when you've lost some of the votes and you're still running that dynamic quorum advantages can come into play. The other thing to keep in mind is Windows also gives an administrator the ability to manually take a vote away. If an admin takes a vote away from a cluster member, dynamic quorum does not give it back. That vote is just gone. So let me illustrate how this works for you. I've got 2 data centers over here. I've got a 6-member DAG, 3 servers in each data center, and the one in green over here is my primary data center, so it's got my witness server in it. So I've got a total of 7 votes, which means to maintain quorum, I need a majority of 7. What's a majority of 7? A little louder. 4, that's right. Okay, now let's walk through some failure scenarios. What happens if I lose the WAN link here? What's going to happen? What's happening on the blue side? What happens on the blue side? That's right. They go down. They lose quorum and they go down. But what happens on the green side? They stay up because they've got the 4 votes there. 1, 2, 3, 4. So we've lost half our DAG, but we still have enough votes over here on the green side to maintain quorum. So because we're able to maintain quorum, dynamic quorum comes in and recalculates the number of votes. Instead of needing a majority of 7, we now need a majority of 4 to keep operating. Okay? What's a majority of 4? 3, that's right. So we lose another vote. We lose a member in this case. Now, have we got 3 votes? Yes, because now we've got a lock on the witness. We always lock the witness when we're 1 vote away from losing quorum. So now we've got a lock on the witness, and we're able to maintain quorum as a result of that. And now because of that, there's only 3 votes. So now we only need a majority of 3 to keep going. What's a majority of 3? 2, that's right. So we can lose 1 more and keep going. Now here's where dynamic quorum becomes really uninteresting from an Exchange perspective. We're down in our DAG to that last man standing scenario. Yeah, we've got another vote for the witness, but from an Exchange server standpoint, the witness isn't doing anything. So what this means now is that the load from the 5 Exchange servers that are now down is now all running potentially on that last single server. Okay? There's a very good chance that that one last server is not going to have enough resources to handle the combined load of the other 5 failed servers. And I will tell you absolutely, we would never ever want you to over-provision a server so it could do that. Okay? Do not overload your servers so that you can get into this one scenario, because what's the problem? Anybody see the problem here besides resource utilization? 0 redundancy, that's right, 0 redundancy. So even if you could get all 6 servers running on one now, you've got no redundancy. That is a terrible, terrible place to be in. So from that perspective, it's not very interesting. Okay, so we'll talk about our guidance around dynamic quorum, but don't think of it as, yay, now my DAG can go down to 1 member and life will be great, and I don't have to worry about it anymore. That's not the case at all. The other thing that you have to worry about is, what if the failure scenario is a little bit different? What if we lost the witness instead of one of the other servers? Okay, so we still maintain quorum. We still have the majority of 2, in this case 2. But what happens in a failover cluster when you get down to the last 2 and you've got dynamic quorum enabled? Then one of them loses its vote and the other one keeps it. Okay, and that could be tricky for the administrator, because what happens if I don't know which one it is? Maybe it's this one, maybe it's that one. I need to know which one it is, because if I shut down the one with the vote, I now have no votes in my cluster, and that last one comes down with it. So I need to know where those votes are. Otherwise, I could take more than one system down by simply rebooting one. Okay, how do I know that? I can use the get cluster node commandlet to look at the votes that are assigned to my cluster members. So there's two columns that you'll look at. The node weight, that's the column where the administrator has the ability to remove the vote away. So 1 means it has a vote, 0 means no vote. So an administrator could set that node weight property to 0, and that permanently removes that node's vote until the admin gives it back. The dynamic weight, that would be dynamic quorum doing its thing. Again, 1 means it has a vote, 0 means it does not. Again, if you take the vote away manually, if node weight is 0, it doesn't matter what dynamic quorum says, the vote is gone for that node. Now, dynamic quorum works with most DAGs. We do not test third-party DAGs. If you're wondering what that is, we do include a third-party replication API so that customers can replace the built-in continuous replication pipeline with a third-party product that uses those APIs. There's only one product out there that actually uses them, and I don't know of a single customer that has deployed it. So all the customers I know of are using the built-in native continuous replication. But because we don't test third-party DAGs, we can't say with absolute certainty that they'll work. But all of our internal testing has it enabled. So all of our daily test passes all proceed with dynamic quorum turned on. All of our Office 365 servers are using it. And although Exchange is not dynamic quorum aware, and dynamic quorum isn't changing the quorum requirements for Exchange, it still may allow your DAG to survive in situations that were unsurvivable in previous versions of Windows failover clustering. So the guidance from both Exchange and the cluster team is to just leave it enabled. It's enabled by default. Just let it do its thing, but don't do any sizing or capacity planning or resiliency planning around that feature. Maybe it might provide you with some benefits, maybe not. It's just the kind of thing where you want to just let it do its thing in the background and not do any planning or anything around it. It'll just be there working. Now, witness server placement, that's something else that has changed slightly in Exchange 2013. And by changed, I mean we give you more options now. Okay, so in 2010, we pretty much wanted your witness server to be in your primary data center, even if you had more than 2 data centers. The architecture of Exchange 2010 did not contemplate and, in fact, specifically rejected the concept of a data center failover. Okay, that was the architecture of 2010. 2013 embraces a data center failover, which means if you have multiple data centers, specifically 3 or more, or as the HAPM likes to say, 2.5 data centers or more, then you can achieve automatic site resilience by having your witness go into that 3rd location. Now, in addition to dynamic quorum, Windows Server 2012 R2 and later also includes dynamic witness. Okay, and this is an easy concept to understand. It's dynamic quorum for the witness server is basically what it comes down to. When the witness server is offline, it loses its vote. When it comes back up, it gets its vote back. Okay, it's the same concept that we apply dynamic quorum to DAG members and cluster members, but now this applies to something outside the cluster, namely the witness server. All right, site resilience has gotten significantly better in Exchange 2013. As a result of the architectural changes we made, we were able to decouple the recovery of the front end from the back end. So I mean decoupling recovery of the namespace or the CAS from the DAG and the back end mailbox service. So that's a huge win. The other significant change is that now most protocol access for the clients into Exchange is all HTTP based. Okay, so Exchange ActiveSync, Outlook Web App, Exchange Web Services, OAB, Remote PowerShell, Outlook, the Exchange Admin Center. These are all HTTP clients. And all HTTP clients have the ability to receive multiple IP addresses for whatever names that they're resolving. And as a result of being able to receive multiple IP addresses for these names, now these IP-based clients, these HTTP clients, have the ability to achieve redundancy and failover at the namespace level. Okay, and I'll illustrate what I mean by that. But basically, the big takeaway is in Exchange 2010, when you think about the DAG and when you think about the namespace and everything that goes around it, in 2010, the namespace is arguably the biggest single point of failure that we have. because it's the namespace that tells the user where to go. So if there's a problem with that, the user's stuck. In 2013, the architecture allowed us to adopt a model that uses redundancy at the client level as well. So now, if the place where the client is trying to get to doesn't answer a TCP request, the client can fail over to another IP address on its own without any admin intervention. And that failover generally will happen for all HTTP clients, so that includes operating systems, web browsers, and applications. It will happen to all of them within about 20 seconds. So there's a 20-second timeout, and on the 21st second, it rolls over to the next IP in its list. So the namespace is no longer a single point of failure. Let me show you what I mean by that. So here I've got two data centers, one in Portland, one in Redmond, and each one of them has a virtual IP associated with it. And inside DNS, I've got the one namespace that I'm using, mail.contoso.com. And so mail.contoso.com resolves to two IP addresses. There's two records in DNS, one that points to the 192 and one that points to the 10.0. Now, in this configuration, at any given time, the server is going to automatically round-robin those addresses to the clients. So ultimately, 50% of my clients are going to connect through Redmond, and 50% are automatically connect through Portland. It'll just load balance those requests between them. But what's cool about this is if I lose Redmond, because I've already got multiple endpoints set up, the client already has that other IP address. So all the client does is once it can't connect via TCP to the 192 address, 20 seconds later, it's trying to make that same connection over to the 10.0 address. Okay? This is not new behavior. This is not unique to Exchange. This has been around on the internet for at least the last decade, if not more. And you can experience this for yourself. If you pull up NSLookup and look up www.bing.com, you'll get a bunch of addresses back. You'll start with a bunch of IPv4 addresses, then a bunch of IPv6 addresses after that, if you have that stack enabled. If you do a lookup again for the same name, you'll see the same list of addresses that are given to you in a slightly different order because the server is randomizing them for each client. So you've experienced this failover capability already. It may have been completely transparent to you, which is the best kind of failover capability, but this has been going on the internet for a long time. Now we embrace it and leverage it within Exchange for redundancy for the client namespace. And of course, the admin has control. If that Redmond site is going to be down for a while, the admin can go into DNS, remove the 192 address from there, and once DNS replication takes place, the clients will then just go to that 10 front door and not have to deal with that 20-second delay. But if it, maybe Redmond's going to be down for just an hour, it may take longer than that for DNS changes to get made and propagate, so they might just leave that going. Sure, some people will go to a dead door, but 20 seconds later, they'll automatically go to the right door. It's really going to be a judgment call up to you as to whether or not you want to manipulate DNS at this point. All right, that's the front end. Let's talk about the back end, recovery of the DAG itself. So same Portland and Redmond data centers, but in this case, I've got a third data center that I can use for my witness. So the witness is in Paris. That would be Paris, France. And the witness is in Paris, France in this example for two reasons. First, this is a behavior I've adopted from the service. In the service, the witness server is always geographically separate from the DAG members. Okay? The reason for that is if you've ever looked at the submarine cable map of all the internet cables that go under the ocean, there are some geographic regions that are only served by a single cable. And if that cable breaks, it takes down everything in that region. So we always have the witness server for all of our DAGs in Office 365 in a separate geographic region so that a network failure of one of our data centers cannot affect the data center where the witness server is. And that's actually the recommendation that we would have for you too. This third data center that you're using really just needs to be isolated from network failures that affect the other two data centers in order for this to work. The second reason it's in Paris is I like to visit my witness server for 2 weeks in the summer every year. And so, no offense if you're in a cooler country. All right, so what happens if we lose our primary data center? Well, in this case, I've got a third data center, and the witness server is completely isolated from that failure. And as long as 3 or 4 have connectivity and one of them can lock the witness server, then you should achieve what we would call a data center failover from your DAG's perspective. Okay? Again, you need 3 data centers to do this. If you don't have 3 data centers, the experience is still a lot better than what we had in 2010. So here's the 2 data centers. Because I don't have a 3rd data center, my witness is in my Redmond data center because that's my primary data center. So same scenario, I lose the primary data center. What happens to Portland this time, though? That's right, lose quorum, so Portland goes down. So you have to do a data center switchover, but the process is significantly faster and shorter than what we had in 2010. In 2010, there were anywhere from 8 to 12 different things that you had to do, depending on your server topology. Here, you only need to do these 3 things. You need to run stop-dag and mark the Redmond site as being down. You need to stop the cluster service on, in this case, MBX 3 and 4. And then you need to run restore-dag and point it to the Portland site. And once you've done that, your 2 boxes will come up and begin using the alternate witness server in the Portland site in that case. So much, much faster activation in terms of a data center switchover. So even if you only have 2 data centers with Exchange 2013, the experience is still much better than it was in 2010. All right, lastly, some best practices. Automate your recovery logic to make it reliable. If you've got certain scripts or certain things that you need to run in order for recovery to take place, like those scripts that I just showed you or those commands that I just showed you on the previous slide, automate those, okay? Think of those recovery actions as you're just doing maintenance because all your recovery actions should not in any way affect service except where you're restoring service. And exercise them regularly. And the last bit of advice I'm going to give you is perhaps the most important bit of advice. Don't let your humanness get in the way, okay? Because humans will like to spend time thinking about a problem and analyzing a problem before they make the decision. And all the time that is going on, service and data access is down and your users are not getting in. So our best practice recommendation is if you have an outage, don't even think about it. Flip the bit, invoke your recovery script, and just do it. Recover service and data access as quickly as you can, then go back and resolve whatever the problem was. After all, that's what we're all going for, whether you're on premises or in the cloud, is happy users who can get a good Exchange experience. All right. Last thing I want to mention, the Solutions Advisory Board. This is an internal Microsoft group of people from Office, from Azure, from Server and Cloud, and so forth. So we know that a lot of you use Exchange with other products, like Exchange and SharePoint, or maybe SharePoint and Azure, or Link Exchange and SharePoint, or Azure and Link, and all that stuff. This is your chance to meet the team that is responsible for crafting those solutions. So you can meet them at the Ask the Experts later tonight and talk more about them. And then if you're interested, you can join their private side session tomorrow as well. All right. And then the last thing is I got to bring up the thing so that you can scan it. All right. So I am 2 minutes over right now. And so I want to be respectful for the next presenter in here. So I am happy to take questions as I'm packing up. But feel free to come see me in the tips and tricks session. And absolutely come see me at Ask the Experts tonight as well. I'd love to talk about this stuff all night if you want. All right. Don't forget to fill out your surveys. And thanks for coming. Every DAG administrator should know. Now, everything I'm talking about applies specifically to 2013. So even if you're running 2010 and you've got a DAG, a lot of this stuff is new and different in 2013. So you won't be able to take all of these lessons back to your environment and act on them right away. But if you are in 2013, then you will want to jump on this stuff. So again, remind me, who is not on 2013? So 2007 or 2010. Wow, that's a lot of you. You guys are missing out. You are missing out big time. Now, sure, the prior versions can do things like automatically recover from disk failures and even some network failures and some server failures. But 2013 now has the advantage of also being able to recover from data center level failures as well. So how many of you are in a site resilience topology where you've deployed your DAG across more than one data center? All right. So that's the kind of stuff we're talking about. How many of you only have 2 data centers? All right. How many of you have 3 or more? All right. Got something for both of you today. Some of the other benefits that you get, failover times. They're half the time or twice as fast in Exchange 2013. Now, in both 2010 and 2013, we talk about database failovers happening within 30 seconds or less, and that's true. But quite frankly, 30 seconds from a computer timing standpoint is a very conservative figure from our perspective. As an example, in our dog food... All right, let's go ahead and get started. Good afternoon. Oh, very good. You're on to me. All right, how many of you were in the managed availability session? All right, we're going to continue a little bit of that discussion in here because there is some managed availability stuff that the high availability team is responsible for, and so we're going to talk about that. How many of you were running 2013? How many of you have deployed a DAG in 2013? How many of you are running 2010? How many of you have deployed a DAG in 2010? How many of you do in 2007? Who's done CCR in 2007? Who likes answering questions? All right, wow, a few hands still went up. Okay. All right, so now we're going to talk about high availability and site resilience. If you are not on Exchange 2013, a couple of these things might be difficult for you to follow along with, but stay with me throughout it. I think it will make sense for you. I'm not going to go over all the individual new features that we have. We've already done those sessions many times. If you're interested in all the HA features, go to channel9.msdn.com and you can see many iterations of the Exchange 2013 High Availability session, which talks about all those features. I will mention a couple of them, but we're not really just going to say, what's new in 2013 because it's been out for a while. And so this session is going to go a little bit deeper into the platform and give you some things that really databases for resilience purposes and recovery purposes. Now we're saying the opposite. We're saying don't use RAID. We're saying use just regular disks. And guess what? On that disk, don't just put one database, but put multiple databases on there. Oh, plus the log stream and the content index for the database as well. And this is, in fact, how we run in Office 365 for all the servers that are running Exchange 2013. And we specifically invented this configuration to handle the disparity between maximum database sizes and the fact that hard drives are getting bigger and bigger and bigger. Okay, so a lot of customers today are buying 4 terabyte hard drives. Some eventually will be buying 6 terabytes, and maybe by this time next year, you might be buying 8 terabyte drives. Okay, but our maximum database size, if you're replicating it, we recommend growing that database no larger than 2 terabytes. So now you have this conflict to resolve. Do you grow the database much larger, beyond the 2 terabyte recommended limit? Or do you waste a bunch of disk space? Well, we don't want you to do either, and so that's where multiple databases per volume comes into play. So imagine if each one of these cylinders were an 8 terabyte volume, you could comfortably fit 2 terabyte databases, 4 of them on one of those disks. Okay, so that's how we get around that problem. We don't want you to grow your databases larger than 2 terabytes, even if you're replicating them, simply because eventually you're going to have to reseeding those databases. And a reseed operation has to complete from start to finish. So if you grow your databases to 3 terabytes, 4 terabytes, 8 terabytes if you want to fill the disk, now you're running into a problem. If you have 8 terabyte database and you need to reseed that, the best case scenario is it will take you 93 hours to do that over your network. Okay, 93 hours is operationally untenable. It's a no-go. But in a multiple databases per volume configuration, if you still have 8 terabytes of data to seed, but it's carved into 4 separate databases, you'll actually be able to reseed all 8 terabytes because it's carved up that way and coming from multiple sources in about 39 hours. It's a much better story that way. So you get faster reseeds. That was actually the point of the bottom one, about 58% faster reseeds when using multiple databases per volume. But at the same time, you're leveraging the full capacity of these disks while still adhering to our maximum database size. So multiple databases per volume. It seems like it might be new and different, and it is, but it's also something that we have a lot of faith and investments in, and it is part of the preferred architecture. All right, so what have we been doing since RTM? We've been doing a lot. And when I say we, I'm really just talking now about the mailbox intelligence feature team within Exchange. This is the feature and component team that's responsible for the high availability features like the DAG and database copies. And it's also the team that owns the extensible storage engine, and our production environments for Exchange 2010. We see database failovers happening in around 20 seconds or less. So for Exchange 2013, we now see database failovers happen in our production environments at about 10 seconds or less. But of course, we can't guarantee 10 seconds, so we generally say 30 seconds or less, your database will fail over and become active somewhere else. So we have done some improvement there. We've also introduced a new architecture design called multiple databases per volume. That's what you see down here in this bottom part of the graph, where literally each one of these cylinders, each one of these gray cylinders at the bottom here, is a single disk. Okay, and by that, I mean like a 7,500 RPM SATA or SAS disk, preferably SAS since they tend to have a better enterprise duty cycle. But SATA or SAS disks are supported. And that's one disk. It's not protected by RAID. It's in a JBOD configuration. That means just a bunch of disks. In other words, no RAID. JBOD is not new. It's actually what we used before RAID was invented. So it's a very old type of configuration. But when you look at this configuration, you realize with 2013 and this type of layout, we're pretty much telling you to do the opposite of what we've told you to do with generally all the other prior versions. So in the past, if you're running 2003, for instance, going a little old school, we tell you, protect your databases with RAID and separate your logs from your